They got 4 blocks of EE. I got the highlighter pen going. That's not going to work. 4 blocks of EE. 1, 2, 3, 4 blocks of EE initially, and then that becomes 2 blocks of EK and 2 blocks of EG. Problem 4A with friction. So it's going to still start out with 1, 2, 3, 4. Throw out a plausible position B L for me here. What do you want? 2EG. So 2EG means it's the same height as it was before. 1EK means it's not going as fast when it gets there. And then we can make this cool by adding in a block of EDIS. So EA equals EGB plus EKB plus EDIS B. What?
Why is the friction if it's in the way?
Great question. So we're talking here, like, have you ever seen like space capsules or like the space shuttle re-entering the atmosphere and they got like all that flame on the tiles? So that's like a really extreme case of smoosh, poosh, and friction with the air. So to a much lesser extent, that's what's happening here. As air goes past it, it's going to slow it down a little. Not going as fast because here we have air resistance. All right. Repeat problem 4A for a system that does not include the spring. And that's kind of like, so when a space shuttle comes into land, again, we talked about that a little bit the other day, it's going like 17,000 miles an hour. When it's landing on the runway, it's got to get down to like a couple hundred miles an hour or it's going to end poorly. Okay, that's not a landing, that's a crash. To do that, they just scrub off a bunch of injury in the atmosphere by using friction with the air to slow the space shuttle down. I say like it's in the present tense. It's we don't have space flight anymore in the U.S. We're garbage, but hey, it's coming back soon, man. Dragon capsule. All right. Repeat problem 4A for a system that does not include the spring. So long story short, what's going to have to happen here if the spring is not in the system? Working is going to occur. Okay. So I've got bricks and earth. And so the injury doesn't start out in the system. 1, 2, 3, 4 blocks of injury. Working, spring, and then that comes in, and it's 4A, so EK is 2 blocks, EG is 2 blocks. Working spring equals EG B plus EK B. All right. Questions or concerns on that? So I want to get to the one where we have working out. We have working in right here.
Working out
6. Okay.
6B.
6B. All right. Are these out of order? Who's 3B? You donkeys. All right. Thankfully, they're numbered. So if you go back in, and I'll try to get better about posting these PDFs so you can go in and look at it later. Or more to the point, your friends that are at the basketball tournament can go in and look later. All right. 6A. We've got 4 blocks of EG. Four blocks of EG becomes 2 blocks of EG, 2 blocks of EE. So there's a reduction in the gravitational injury, okay, because it's at a lower level. So stay tuned for that because that's about to get really weird here in a couple of days. But moving closer towards the center of the Earth is a reduction in gravitational injury. That will always be the case, but we're going to quantify it weirdly later on. So same problem, chords are not part of the system. That means we're going to start out with 4 blocks of EG. And in the end, I'm going to have 2 blocks of EG. But I only have jumper and earth. So EG at A right now does not equal EG at B because we've got to have some working. I'm going to send it out this way. So there's 2 blocks working chord. Okay, and that's happening in B. Okay, so we got to have some consistency there. Now, let's look at the same problem and let's pretend that I set how do I want to swing this? Let's pretend that I set y as 0. Okay, what do I want to say here? HA equals 0. So then when I go to do my L, I would say it's at 0. Okay. And there's no elastic injury there initially at A. And let's say the height at B is negative something. It's less than 0. That would be the simpler way to say it, right? HB less than 0 meters. I'm not sure at what point in the unit I usually throw this out there, but I'm going to throw it out there today because, hey, man, you're all doing such a great job of paying attention. I want to make sure you don't miss out on this bit. So the initial total injury is 0. And then in the end, we're going to have 2 blocks of elastic injury. The system is earth, jumper, cord. I got no injury over there. Okay? I got 2 bricks of elastic injury here. E at A equals 0. That's got to equal E at B. I have 2 blocks of elastic injury. Mathematically, how are we going to make this work? What do we got to do? Run it by your neighbor. Why did Mr. Harding leave that space there between EG and EE? Ooh. Nat's got the suggestion that we have negative blocks. What? Okay. And so then if I do EG at B plus EE at B, that's going to equal the same total injury that we had previously. It still adds up, okay? But we had to invoke negative injury values here gravitationally because I set the height at A, okay? I heard the word arbitrary earlier. The level that you want to set the gravitational injury to 0 at is arbitrary. That's a choice that you make. And if I set it to initially be at 0, then in terms of economics or whatever, this is how I balance the books. The gravity is going to have to go into the negative now that we're lower. It still works out that we got a total energy of 0, so it's all cool, all right? Where you choose to put the gravitational injury to 0 is an arbitrary choice, okay? And it turns out that for like most problems, conveniently it's at the floor level. But if we're flying in an airplane and I drop a book on Andre's foot to make him shut up, then I don't want to use the ground level as 0, okay? It's only going to fall 4 feet or whatever. So I'm going to use like the floor of the airplane at 0. When we start to get to really big level stuff, though, universe level stuff, dismiss you. When we get to really big level problems, where is 0 set? Where is 0 for gravitational injury? That would be rather arbitrary. The center of the earth is not important. It's set at infinity. 0 is at infinity. So we'll deal with that later. All right. Adios. Robots. Sorry, trobots. No, robots.